This is SpaceTime Series 27, Episode 11, for broadcast on the 24th of January 2024. Coming up on SpaceTime, claims Mars could have had flowing water for hundreds of millions of years. New Webb Space Telescope data shows that early galaxies looked a lot more like pool noodles than surfboards. And NASA's new mission to capture star stuff. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study based on Martian impact crater erosion rates suggests water may have flowed across the surface of the red planet for hundreds of millions of years. The findings, reported in the journal Earth and Planetary Science Letters, looked at the maximum timescales for the formation of Martian river valley networks shaped by flowing water. The study's lead author, Alexander Morgan from the Planetary Science Institute, says that while the red planet is a global freeze-dried desert today, its surface preserves extensive evidence of past flowing water, including what appears to be river valleys. And the timescales over which these river valleys formed could have big implications for early Mars habitability. That's because long periods with stable liquid water would be more conducive for the formation of life. The red planet's river valley networks formed more than 3 billion years ago and have long been considered among the strongest pieces of evidence for liquid water on early Mars. Previous research has already shown that it would have taken a minimum of tens of thousands of years to erode these river valleys. But the frequency of flow events, and consequently the total amount of time over which the river valleys formed, has never been constrained. And that's where this new work comes in. Morgan and colleagues used craters that both predate and postdate the river valley system in order to place maximum bounds of hundreds of millions of years on the era over which these systems formed. Now, given what scientists already know about erosion rates on early Mars, longer timescales implies that the conditions permitting rivers to flow would have been highly intermittent, with long arid periods interspersed with brief periods of fluvial activity. Morgan says scientists studying early Mars have historically tended to fall in one of two camps. Early Mars was either a warm, wet world with oceans, or it was a cold, frozen place with massive ice sheets. Over the past decade or so, scientists have come to realize that these descriptions are far too general, and it doesn't really make any sense to try and condense hundreds of millions of years of planetary climate history into just a 2 or 3 word description. You see, like the early Earth, early Mars was a more complex place, and the conditions permitting surface water on Mars would have also varied considerably. Morgan points out that Earth has undergone massive climatic changes throughout its history. For example, 20,000 years ago, the area, what is now Chicago, was beneath half a mile of ice. And in the same way, climatic surface conditions permitting rivers to flow on early Mars likewise would have probably waxed and waned. So looking at the overall results, it suggests that Martian rivers were eroding at very slow rates, similar to parts of the Atacama High Desert in Chile today. One explanation for this is that erosion might have been inhibited by the accumulation of large boulders on the riverbed, which could not be further broken down. Another possibility, however, is that rivers were simply flowing very infrequently, maybe as little as once in 100 years. And that would imply that rivers on Mars were generally dry, but could become active when something like, say, volcanic activity or variations in the planet's axial tilt and its orbit around the Sun warmed the Martian surface more than normal. These long-term climatic changes are not unusual because they also happen here on Earth. Earth's axial tilt often changes, as does its orbit around the Sun. We call these Milankovitch cycles, and they're responsible for many of Earth's glacial periods. Morgan says that over short timescales, river flows are controlled by rainfall or upstream snowmelt. But when looking over longer timescales, it's clear that Earth's rivers are affected by climatic changes. For example, 20,000 years ago, there were large lakes and rivers flowing across what is now Nevada. And Martian rivers could have operated in much the same way, with short-term viability due to storms and snowmelt, and long-term viability due to changes in the planet's spin or its orbit around the Sun. This is SpaceTime. Still to come. New Webb telescope data shows that early galaxies looked a lot more like pool noodles and surfboards than the frisbees and volleyballs they commonly look like today. And we take a close look at NASA's new mission to capture star stuff. All that and more still to come on SpaceTime. New images from NASA's Webb Space Telescope shows that early galaxies at the dawn of time are often flat and elongated, looking a lot more like surfboards and pool noodles than the frisbees and volleyball-shaped galaxies we see around us today. The findings, reported in the Astrophysical Journal, suggest that today's more common spherical-shaped elliptical galaxies and disc-shaped spiral galaxies were very uncommon in the early universe. The study's based on observations using Webb's Cosmic Evolution Early Release Science Survey. Astronomers focused on galaxies estimated to have existed when the universe was between 600 million and 6 billion years old. The study's lead author Viraj Pandya from Columbia University says roughly 50 to 80% of galaxies studied appear to be flattened in two dimensions. Galaxies that look like pool noodles or surfboards seem to be very common in the early universe, which is surprising considering they're very uncommon today. But while most of the distant galaxies look like surfboards and pool noodles, there were some which were shaped like frisbees and volleyballs. The volleyball or elliptical-shaped galaxies appear the most compact type in the cosmic ocean in early times, but were also the least frequently identified. On the other hand, the frisbee or spiral-shaped galaxies, while still rare, were found to be at least as large as the surfboard and pool noodle-shaped galaxies, but became more common as the universe aged. And the observations raise an interesting question. See, our Milky Way is about 12 billion years old. So when it started to form, it would have formed right at the time when there were lots of pool noodles and surfboards. So what would our spiral Milky Way galaxy have looked like back then? Well, according to the authors, their best guess is that it probably would have looked something like a surfboard. This hypothesis is based partly on new evidence from Webb. Theorists have wound back the clock to estimate the Milky Way's mass billions of years ago, which would correlate to the shape it had at that time. See, these distant galaxies are all far less massive than nearby spirals and elliptical galaxies which we see today. That's because in the early universe, galaxies had far less time to grow. The authors say the question now is to determine how galaxies reach their shape through their process of merger and evolution. This is SpaceTime. Still to come, NASA's new mission to capture star stuff, and later in the science report, paleontologists discover a new species of tyrannosaur that's the closest relative yet of the famous Tyrannosaurus Rex. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, NordVPN. If you're a sports fan, you know the struggle of missing out on that big game, especially when they're simply not available in your country through geo-blocking. Well, that's where NordVPN comes in. It's quite literally a game changer for sports fans worldwide. With NordVPN, it's like having a front row seat to your favorite global sports action. Whether you're traveling or simply living in a place where your favorite sports aren't being broadcast, NordVPN makes it easy. You just switch your virtual location and voila, access streams and content from back home or any corner of the world. But that's not all. NordVPN also helps you navigate around all those annoying digital roadblocks and censorship, giving you complete freedom to use the web exactly how you want to. So, say goodbye to missing out on social media updates and exclusive content just because of where you are. And the best part, NordVPN offers you a 30-day money-back guarantee. That's right, you can try it out, and if it's not living up to our promise, there's no cost to you. Zero. Nada. In other words, there's no risk and you get all the rewards. Now, if you're ready to join NordVPN's winning team, head over to nordvpn.com/StuartGary and click on the Get the Deal button. That's nordvpn.com/StuartGary and click on the Get the Deal button. And remember, it's all totally risk-free with Nord's 30-day money-back guarantee. Now you can find all the details in our show notes and on our website, so don't miss out. That's nordvpn.com/Stuart Gary. Secure your spot in the global sports arena with NordVPN. And now, it's back to our show.
You're listening to SpaceTime. SpaceTime with Stuart Gary.
Scientists are working on a new instrument to capture stardust from interstellar space. The instrument, called the Interstellar Dust Experiment, or IDEX, will be a key component of NASA's new Interstellar Mapping and Acceleration probe, IMAP, which will launch in just over a year from now. The IMAP spacecraft will travel to a gravitational well between the Earth and the Sun, known as the Lagrangian L1 position. It's located about 160 million kilometres from Earth and is a point in space where the gravitational forces of the Sun and Earth tend to cancel each other out, thereby allowing a spacecraft to remain in orbit at this position with very little expenditure of fuel. From its perch at L1, IMAP will spend 2 years collecting and analysing the composition of literally hundreds of thousands of microscopic dust particles floating past. Now, a lot of these will be particles in the solar wind streaming out from the Sun, as well as from passing comets and asteroids, and the zodiacal light, which are particles blown into space by massive dust storms on the red planet Mars. But also included in the catch will be grains from interstellar space, particles flowing into our solar system from the vast expanses between the stars in the Milky Way galaxy. These will include dust particles from other star systems and the remains of exploded stars called supernovae. Supernovae are important because it's thought one supernova explosion not too far from where we are now probably triggered the collapse of a molecular gas and dust cloud which wound up forming our Sun and solar system 4.6 billion years ago. But interstellar dust grains are spread so thin, the instrument will probably only collect a few hundred of them during its lifetime. And so each and every small speck of interstellar dust will be a treasure trove of information. Of course, most of them will have been altered as they travel through interstellar space, but they'll still be the closest material we have for understanding the original building blocks of our solar system. So far, astronomers have only ever captured just a few dozen grains of interstellar dust, and that will make each new find by IDEX precious. Detecting and analysing them in space will open up new windows into the universe. Built over the past 6 years by a team at the University of Colorado Boulder, IDEX will be one of 10 scientific packages aboard the IMAP spacecraft. IMAP's being assembled at the Johns Hopkins University Applied Physics Laboratory in Maryland. The IDEX instrument looks a lot like a large drum. It features a 50 centimetre wide aperture at one end designed to capture dust zooming by, sort of like a baleen whale feeding. IDEX will record how fast these particles are moving, what they're made of, and the direction from which they're coming. And this isn't the team's first project. They previously designed and built a similar instrument called the Surface Dust Analyzer, or SCUDA, which is part of NASA's Europa Clipper mission, which is slated to launch to the Jovian Moon later this year. And they built an earlier version, which was mounted aboard NASA's New Horizons mission spacecraft to Pluto. It's now exploring the dark outer reaches of the solar system. IDEX project manager Scott Tucker says trapping dust in space is no easy feat. That's because interstellar dust particles are very rare. His team's made the instrument roughly 2.5 times bigger than SCUDA because the bigger the mouth, the more particles you can catch. Each grain of dust will likely be rich in elements like silicon and carbon and may only measure a few millionths of a centimetre across. Making things more difficult, some will be travelling at speeds of well over 100,000 kilometres per hour. And as these grains crash into the back of IDEX, they'll instantly vaporise in a cloud of ions, which the instrument will then collect and analyse. Tucker says the main challenge with IDEX has been what engineers refer to as dynamic range. See, the instrument needs to capture both really fast and large particles as well as smaller, slower moving ones, and then measure them all using the same instrument. This report from the University of Colorado Boulder.
Interstellar dust from outside our solar system enter our solar system, and we don't know a lot about its composition, mass, and speed. And so IDEX, throughout its orbit, will be able to answer some questions that kind of remain unanswered from past missions.
IDEX, first of all, is an instrument one of the instruments on the IMAP mission. IMAP is going to fly to a location called L1, which is Lagrange point 1, which is about 1% of the way from the Earth to the Sun. And it's going to sit there. IDEX is going to look off into space, and it's going to measure interstellar dust particles that arrive at that point in space.
This is a way for us to learn more, not just about our solar system, but a way for us to learn about extrasolar systems. And instead of just looking at the light that those systems produce, we can actually get the material that is coming into our solar system. And so we have this chance and opportunity to learn more, not just from our traditional light model, but from a chemical standpoint, what some of those building blocks of other planets and systems might be like.
The interstellar dust, it's not quite as affected by the sun, and it doesn't collide with other dust quite as often. So it's the same way that it was millions of years ago. So by looking at these dust particles, we can get some information about what our solar system was like many, many years ago.
And in that report from the University of Colorado Boulder, we heard from IDEX project manager Scott Tucker, IDEX instrument engineer Christina Davis, and IDEX research assistant Ethan Yari. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The World Meteorological Organization has confirmed that 2023 was the hottest year globally since records began. Following their original declaration back in November last year, the organization has consolidated data from 6 leading global weather monitoring datasets, concluding the average annual global temperature for 2023 was 1.45 degrees, plus or minus 0.12 degrees Celsius, above pre-industrial levels. Considering the shift from La Niña to El Niño conditions in late 2023 and the continuing presence of El Niño today, the World Meteorological Organization says it's now possible the 2023 record could be broken in 2024. Researchers have taken the first critical step in creating a successful HIV vaccine. A report in the journal Cell claims researchers activated specific immune cells that induce broadly neutralizing antibodies. The study confirms that these antibodies are, at the structural and genetic levels, similar to human antibodies needed as the foundation for a protective HIV vaccine. The authors had previously isolated naturally occurring broadly neutralizing antibodies from an individual and then backtracked them through all the changes the antibody and the virus underwent to reach a point of origin for the native antibody and its binding site on the HIV envelope. This allowed the authors to engineer a molecule that elicits antibodies that mimic the native antibody at its binding site on the HIV envelope. The human immunodeficiency virus, HIV, is an infection that attacks the body's immune system, causing acquired immunodeficiency syndrome, or AIDS. It's thought to have originated from infected primates in Western Central Africa and was first identified in humans in May 1981. HIV targets the body's white blood cells, specifically helper T cells. It also attacks macrophages and dendritic cells, weakening them and causing a progressive failure of the immune system. This allows a wide range of so-called opportunistic diseases such as tuberculosis and several types of cancer to become critical, eventually killing the patient. The World Health Organization estimates at least 52 million people have been killed by AIDS, with another 40 million currently living with HIV. Paleontologists have uncovered a new species of tyrannosaur that may be the closest known relative to Tyrannosaurus rex. The new theropod dinosaur, named Tyrannosaurus macronesus, was found at the Hall Lake Formation in New Mexico. The findings, published in the journal Scientific Reports, are based on a fossilized jaw and partial skull originally thought to belong to a T-Rex. However, numerous subtle differences in the shape of and joins between the skull bones eventually led the authors to determine it belonged to a new and different species. The jaw of Macronesus is far more slender than the more robust lower jaw seen on T-Rex. The other main difference lies in the prominent ridge or postorbital bone. That's the bone around the eye. That might have something to do with how the species attracted a mate. The new tyrannosaur is thought to have lived between 71 and 73 million years ago. That's between 5 and 7 million years before T-Rex. Samsung have just released their new Galaxy S24 lineup, and it's full of new features which will force Apple and Google to up their game. The new Galaxy smartphone includes a range of AI capabilities, including photo editing using the new Snapdragon 8 Generation 3 chipset for improved graphics and AI features. With all the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
This is Samsung's attempt to make AI effortless. The creativity that it can offer for end users, be it text messages, a thing called Circle to search. Cameras, a new 5x optical zoom camera with a thing called nightography, where it takes excellent low light photos and videos with a 60% larger pixel size for the camera sensor, and a new, stronger optical image stabilizer, so that when you are taking these long shots with the zoom, they are as sharp and as clear as possible. And you also now have a thing called a flat screen, so it's much easier to apply screen protectors and also better for writing on. The S24 Ultra has a titanium frame, so matching the iPhone. The S24 and S24 Plus have aluminium frames, and they also have the Qualcomm Snapdragon 8 Gen 3 chip, the one that's supercharged with AI smarts. But of course, there's a special Galaxy edition, and that allows you to do things like translate live in one of 13 different languages whilst you're having a phone call. So when you're talking to somebody and you're in English, they're in Spanish, for example, you can choose the languages. I think you can detect it, but certainly you can choose the languages you want. You speak, it translates. They speak, it translates. And you can have a conversation. And I tried it at CES. There was an embargoed session where I gave it a go, and it works. Very cool. Then you've got this circle to search, so you can tap the little white line, which is the home button effectively now. Normally you'd swipe up, but you hold your finger on that. Then in any video, any web page, anywhere that you are, you can then circle around something with your finger or the stylus. And Google search, and this is done in conjunction with Google, it will search just for that. So you can do a visual search of anything, which is extremely cool. You can now type messages in one language and have them appear in another via the same live translation capability. You can now have HDR photos, not just in the main camera app, but things like Instagram. You can also write something in the note-taking app or just anywhere. And then the keyboard allows you to change the tone of what you've written. So an informal tone to your friends or a formal tone for your boss. If you're typing things out or even handwriting them, the Note app can take your wonky handwriting and make it nice and straight. You can take your notes and put it into bullet point format and give it proper headings. If you are recording your voice and you've got multiple people, you're recording a session, it can break the voices up into speaker 1, speaker 2, speaker 3. It can transcribe it all for you. You can even translate that to a different voice, and that's just for free, part of the system. Normally you'd have to pay $20 a month to a service like Otter.ai. And there's just so many cool little features inside. But this is Samsung throwing down the gauntlet to Apple, to Google, to everybody to say, look, this is the new standard. And Samsung is backing that up with 7 years, not just of security updates, but operating system updates. That's to match what Google has promised for its Pixel phones, and also to outclass Apple where it can, who normally does at least 5 years. I think the one thing that Samsung still doesn't have nailed down is the ability to get the updates out on the same day simultaneously for all of its phones globally. And that's something that Google can do because it has a much smaller series of phones. Samsung has a very wide collection of phones. Samsung just lost the crown for selling the most smartphones to Apple in 2023, and I'm sure they want to get it back. They've got more competition than ever. Very impressive phone. Google's going to have to do some big work to match the features with their Google Pixel 8 and 8 Pro with their feature drops. And of course, we're expecting great things from Apple at the Worldwide Developer Conference in the middle of this year with iOS 18 and all of the AI updates, and also with their iPhone 16 Pro. So great news for smartphone owners.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.